Polyethylene is an addition polymer. No water gets formed. The way you want to figure out if water gets formed is normally we make water by adding an OH, might be from an alcohol, might be from an acid, to a hydrogen from something else. So if you notice that the monomer doesn't have any OH in it, then it's not going to be a condensation polymer. It's just going to be an addition polymer. So polyethylene is an addition polymer. The monomer is your ethylene molecule, and you use a titanium chloride catalyst. The 3 in the brackets implies that it's TiCl3 or a Ziegler-Natta catalyst. Those names aren't so important, but if you're doing a longer response, it's always good to bring in that extra detail. So that's what I've been telling you guys for a while, is some of this stuff isn't necessary, but it's really important for elevating the quality of your response. In schools, it's not so important because they're going to give you the marks anyway, but in terms of ranking you guys amongst how many students are there in chemistry, 11,000 students in the 2023 this year HSC, you want to make your answer stand out. So that extra detail is still nice to remember, nice to bring in. So what happens with your polyethylene, or when you're adding anything together? So similarly to your addition reactions for your alkenes and your alkynes, addition reactions in polymers happens when the double bond breaks and then single bonds form and stuff like that. So same exact thing happens. Yeah. The only difference is now that the single bond forms between the same molecules. So you have something like this. That's your ethene molecule. What happens is that double bond is going to break. And now, because that double bond breaks, the carbon only has 3 atoms bonded to it, 3 bonds. So it can add a fourth bond. So what that fourth bond is going to come from, it's going to come from a different ethene molecule where the carbon atom has also been broken. So what happens then is that this ends up bonding to this. So it should just be a bolded line here. And then that'll just keep on happening. So there'll be another carbon here, another carbon here. And each of these are going to be your monomer units. And then as it adds on, that's going to be your polymer. One of the types of questions you're going to get, it might either be giving you the monomer and they'll ask you to draw in the polymer. So you'll have to be able to see where the double bond is and where the next monomer is going to add to. That's something we'll practice together at first, because like I said, it looks confusing at first, but once you get the hang of it, it's relatively simple. Or the other type of question they can give you is they'll give you the actual polymer, like the repeating units, and you'll have to be able to see just physically which blocks are repeating. And then they'll ask you to pick the monomer from that. I haven't seen that. So in terms of drawing the monomer and the polymer, haven't seen that yet as a short answer question. Normally in HSC exam papers, they give it to you as a multiple choice. So it's easier because then you can see what the options are. But I have had trial experiences like in schools where they do actually give you the more challenging question and they ask you to draw it yourself, which means figure it out yourself, and they don't have drawings to let you pick and choose 1 out of 4. Okay, so that's the kind of questions you can get. Now, in terms of properties and uses, okay, the properties you derive based on this structure. Yeah, so we'll do the first one together, but as you go through this, you should be able to get a bit of practice and then be able to figure out the properties of the next few on your own, actually. So with polyethylene, it's not as rigid as other plastics. Okay, so polyethylene gets used to make like your paper bag, sorry, not your paper bags, what am I saying? Your plastic bags and things like that, and your water bottles, like the really bad quality ones, like the Mount Franklin that like scrunch up really badly. So that's polyethylene, yeah? So polyethylene isn't as hard, isn't as rigid as other plastics. It's really ductile, which means that you can bend it a lot. And but it's also high impact strength. So what that means is that even though you can like scrunch it up and it's not that hard, it won't break down. So you can apply a lot of impact to it and it won't just like crack and your water won't spill everywhere. Now, You can actually get high density polyethylene, which is a bit harder, or you can get low density polyethylene, which is a bit softer. The way you make high density polyethylene, the two different ethylenes, depending on what kind of catalyst you use, but you can also make polyethylene low density by adding what you call plasticizers. Plasticizers, the way you want to think about it is they're sort of like pretty much little bubbles that go in between your polyethylene chains. So if you think about a plastic, yeah, the reason why we can turn this really long chain into like a chair or into a water bottle is because the chain, I'll just do this, and then the hydrogens as well, is the chain like adds up to each other, right? So things like that. So that's how you see water, and that's how you see like mercury or like bromine and stuff. So the molecule itself looks really small, but the reason you're able to see it is because they're in really big quantities, and obviously they have intermolecular forces between each other and stuff. So that's why plastic chairs and plastic bottles and things like that exist, because the chemicals add up together and ends up being something you can see physically. But obviously it takes millions and trillions of those molecules to get a physical thing. Plasticizers go into each of your carbon chains and it spreads it out. So you can sort of think of it as like a gas bubble. So if you do that, you can actually spread out the polyethylene, make it a little bit lower density. High density polyethylene is used to make like your plastic chairs and stuff because they're a lot harder. Obviously you can sit on them. Low density polyethylene is used for like the softer stuff, which is plastic bags, water bottles, and things like that. Okay. Now, why is polyethylene kind of ductile and not why is polyethylene ductile and still have high impact strength? It's going to only form weak dispersion forces. So that's why it's able to be ductile, just because the forces within it are so weak, which means it's not being held together that much. So you can sort of like bend it and shape it and stuff like that. But the reason why it's still able to withstand high impact strength is because unlike a really small alkane, this is a really big polymer, which means even though weak dispersion forces are weak, one of the things we've talked about before when we talked about properties of alkanes and blah, blah, and things like that is weak dispersion forces are weak, yes, but if you have a really big molecule that can form a bunch of weak dispersion forces, that force, the strength of that force still adds up to be something quite big. Okay, so that's why propane, oh sorry, that's not a good example. Propane is only 3 carbons. That's why something like pentane, which is 5 carbons, is still stronger than methane, which is 1 carbon. Pentane still forms weak dispersion forces, but it has 5 carbons instead of 1. Okay, so similar to this, it's ductile because the weak dispersion forces are weak, easy to crunch and stuff like that. But even though it's easy to move around, it doesn't break apart because those weak dispersion forces, there's so many of them, it still holds it together. Okay, so that's that. Gives you some numbers on the melting points of HDPE, which is high density polyethylene, and LDPE, which is low density polyethylene. Once again, numbers are always good to bring in because they're specific, not necessary, but gonna elevate the quality of your response. Okay, good. Now, in terms of uses, okay, we've already related this, but you want to write your answer in a way that allows you to relate the properties to the uses, because that's the way things get done. You want to see what something is good at and then relate it to something else. Okay, because it's ductile and it has really high impact strength, it's easy to shape, but it's also able to hold a lot of weight, which means you can shape it into a bunch of different packaging products, but then also put a lot of stuff in it. Yeah, so packaging products is what it can be used for. If it's high density polyethylene, which means it's slightly thicker, it can be used for like the chairs. So the chairs that you sit on at school, if you guys have the same chairs that I used to have, but like the stereotypical Australian public school chairs, if you guys know what I'm talking about, the chunky kind, the chunky plastic ones, is going to be made from HDPE. Okay, so high density polyethylene. Toys, garbage garbage bins, the ones you reel out or your parents reel out at to the front of the house, and then council cleans it and stuff like that. That's going to be HDPE as well. And then low density polyethylene is going to be your softer stuff, which is squeeze bottles for like sauces and things like that, garbage bags and food packaging, so like your cling wrap and things like that as well. Polyethylene for pipes and fittings. Because it's non-polar, it doesn't react with water, it doesn't absorb water. So that's another reason as well. Non-polar doesn't form any dipole-dipole forces with water, and therefore it doesn't absorb water, which means it's really good for pipes. And then cable jacketing. Does anybody know what cable jacketing is? Based off the name, okay? Use the brain tricks that I've been telling you. Cables is like wires and stuff. What do you think cable jacketing is?
Is it like a protective layer on the outside of the cable?
Yeah. Okay. So you know when you see cables, like if you ever have like earphones break apart or something, you see the wire inside of it. Normally it's like orangey kind of stuff because it's copper wire. And sometimes you'll get a bit of red or a bit of blue and stuff. The plastic stuff on the outside of that, that's the jacket. So that's the cable jacket. You can use polyethylene for that as well. Slightly lower density polyethylene because it's pretty soft. Because it insulates current, which means it's not going to come out and it's not going to, what's it called, electrocute you. Okay, so that's polyethylene.